guru AYU mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, salam sejahtera dan hai semua. Ibu bapa dan semua pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha e-didik Malaysia dan GAP Kulu Malaysia. Bermula percuma selamanya percuma. Pada petang ini, kita akan bersiaran langsung daripada channel saya dan juga channel Cikgu Izyan dan juga Cikgu channel Yani. Siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada saya. So, nama saya adalah Mr.Peh KH, kini mengajar di Oleh Tingkatan 6 Tempat 5 Melaka. So, kita akan belajar subjek Fizik Tingkatan 4 untuk hari ini. So, kita akan adakan kelas selama 1 jam. So, sebelum kita teruskan kelas, suka cikgu ingatkan kepada para pelajar dan penonton yang lain yang ingin menghantar komen, sila gunakan bahasa yang sopan dan gambar profil yang bersesuaian. Untuk tontonan umum, cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. So, dengan tidak melengahkan masa, so saya mulakan kelas pada hari ini. Okay, so I am Mr.Peh. Currently, I am teaching at College Tingkatan 6 Tempat 5 Melaka. And today we are going to our last subtopic of chapter 4. That is the gas law. So we are going to learn 3 gas law, which is the Boyle's law, Charles' law, and Gay-Lussac law. Okay, so before we go to the class, this is information to let you know. So we have actually 2 classes of the 3 tuition online class. Okay, so the Form 5 class will be held on every Friday, 9:30 a.m. and 9:30 p.m. So now we are at chapter 4, transformer, and presented by Cikgu Rosemawati. And another class will be like today. So it's actually Sunday, 3:30 p.m. Okay, so this is the Panitia Fizik KSSM Akademi Youtuber Malaysia. So today will be only me together with you all at Conti. Okay, so because the Cikgu Izyan is actually sick and actually she is another teacher is actually duty to me and with me today. So I hope that she can recover soon. Okay, so today's subtopic you are going to cover about 5 learning standards. So the learning standard 1 will be you need to able to explain the pressure, temperature, and volume of gas in the terms of the behavior of gas molecule based on the kinetic theory of gas. Okay, so the first pressure, temperature, and volume of gas. So there are three physical quantities involved in the gas molecule in closed container based on the kinetic theory of gas. Okay, so the quantity physics here referring to the first will be the pressure. Okay, so as we know already, gas molecule always move randomly, just like the figure show here. Okay, so you can see the blue dot and the red dot here move freely. Okay, so when gas molecule collide with the wall or container and revolve, so you can see here the black color line will be the showing the closed container. Okay, so when the molecule collide to the wall container, okay, so the particle will be rebound and the force will be exerted on the wall container. So that force per unit area is actually the formula for the pressure. So that means F over A will be cause the pressure exerted at the wall container. Okay, so here you can see when the rate of the collection between the gas molecule and the wall container increases, the force per unit area increases. Therefore, the gas pressure will be also increases. So this is regarding the pressure. So that means the pressure is actually measuring for the rate of collection of the gas molecule against the wall container. Okay. Then the next will be the temperature. Okay, so here when the gas molecule move at higher speed, average kinetic energy of gas molecule increases with the temperature. Okay, so here you can look at the GIF, the blue color dot, where at the cold condition will be moving at the lower speed, while the red color dot showing at the hot region will be moving at higher speed. So another GIF here you can see the kinetic energy formula where you already learned at PhD level is actually equal to 1 over 2 mv squared. So that when the V increases, so the kinetic energy will be increases lah. Okay, so you can see here the cold particles will be moving at lower speed, so the kinetic energy will be lower. On the other hand, at the hot region, the particle is moving at the higher speed, so the kinetic energy will be higher lah. Okay, because the temperature is actually measuring the average kinetic energy of gas molecule. So the higher the kinetic energy of the gas, the higher the temperature. Then another physical quantity involved in the gas law will be volume. Okay, so gas molecule move freely and fill the entire space of the container. So you can see here we have the GIF. So when the container volume decreases, you can see the particles will be occupied at a smaller volume lah. So when the volume of container increases, so the gas molecule will be occupied for bigger volume. Okay, so that we can conclude that the volume of gas is same as the volume of container. Okay, so here, if I say you haven't downloaded my worksheet for today's, okay, you may download my worksheet today with the link below. So the link will be this. Okay, so welcome to download the worksheet for today's lesson. Okay. Okay, then the next, we need to introduce the gas laws. Okay, so as I mentioned just now, today we are going to learn 3 gas law. Okay, so the first gas law will be Boyle's law. Okay, so what is the Boyle's law? Okay, so the Boyle's law said that pressure P is inversely proportional to the volume for the fixed mass and constant temperature. So we'll be using this formula lah. Okay, P is inversely proportional to V. Okay, so that means that when the V increases, so the P will be decreases lah. Okay, so later on we will discuss detail for each gas law. Okay, then the second gas law involved here will be Charles' law. Okay, so Charles' law said that volume is directly proportional. V is directly proportional to the absolute temperature at the fixed mass and constant pressure. Okay, so that means that the temperature increases, the volume will be increases lah. Okay. Okay, then the next here will be third gas law here, Gay-Lussac law. Okay, so the Gay-Lussac law is actually also can known as the pressure law. So both is actually referring to the same law. Okay, so pressure law will be same as the Gay-Lussac law. Okay, so the pressure law or Gay-Lussac law state that pressure, we use symbol P, okay, is directly proportional to the absolute temperature for fixed mass and constant volume. Okay, so here will be the equation, okay, represents the Gay-Lussac law. So that means that when the temperature increases, the pressure will be increases. Okay, so this is the definition for the each gas law involved in subtopic today, okay, which is the 4.4 gas law here. Okay, so we have already complete our first learning standard. So now we go to our second learning standard here. Okay, so you can see here the learning standard 2 will be you need to able to understand the experiment where can be used to determine the relationship between the pressure and volume. As per mentioned just now, okay, so the Boyle's law will be the law which is going to relate the pressure and the volume when the mass of the gas is fixed and the temperature is constant here. So that means the fixed or constant variable for Boyle's law will be the mass and also the temperature. Okay, so let us go through detail for the first law, which is the Boyle's law here. Okay, so Joseph, welcome to my lesson, to my class. Okay, so I hope that you can join my discussion. Later, any question can just type at your chat room. Okay, so the Boyle's law is actually going to investigate to determine the relationship between P and V. Okay, and then just now we also already introduced to you the definition for the Boyle's law. So the Boyle's law stated that the pressure will be inversely proportional to V, where you can simplify by this equation. Okay, so the Boyle's law can be explained by using the kinetic theory of gas. Okay, so you can see here. So the diagram shows, a fixed mass of the gas compressed at constant temperature. So you can see here. So this is initial of the condition. Okay, so showing the crater volume actually. Okay, so the red dot here is the air particles. Okay, and then we can compress and make the volume decreases. You can see less volume. Then as mentioned just now, the mass will be fixed. So you can see the numbers of particles here is actually the same. Okay, so you look at the second sentence here. When the volume of gas decreases, will be this figure lah. The same numbers of molecules move in smaller space. So you can see still have 3 particles, but now the volume becomes smaller. Okay, so what is the impact here? So therefore, the numbers of molecule per unit volume increase. So the numbers of particles the same, but numbers of molecule per volume increase. Okay, because volume decreases, so that the numbers of molecule per volume increases. And this will cause us the rate of correction between the molecule against the wall or container increases. So that means when at smaller volume, the particles will be collide more frequently to the wall or container. So as per mentioned just now, the pressure is actually measuring the rate of collection of the molecule against the wall or container. So when the particles collide more frequently, so the pressure will be increases. Okay, so you can see force per unit area of the wall container increases. Okay, so the pressure increases now because the F over A is actually pressure, just like I explained to you already at learning center 1. Okay, so that means here when the volume decreases, pressure will be increases. This is the P inversely proportional to V lah. Okay, so this is can be explained through the kinetic theory of gas. Okay, and then the next here will be the definition where actually I already explained just now, and I explain here again. Okay, so Boyle's law state that pressure P is inversely proportional to the volume for a fixed mass of the gas at the constant temperature. So that means here P will be responding variable actually. Okay, and then the V here will be the manipulator variable, and the mass and the temperature here will be the constant variable. Okay. Okay, again, you can simplify and memorize like this formula. Okay, P is inversely proportional to V. Okay, so with this formula, we can form another formula here. Okay, so here you can see P inversely proportional to V. So here the K here is the constant. Constant. Okay, so will be equal to PV. So we moving the V to another side. So we get PV equal to constant. Okay. Okay, so we count the formula. P1 V1 equal to P2 V2. So P1 will be pressure at initial condition. Volume 1 will be the volume at the initial condition. Okay, and then P2 will be the pressure at the final condition, as well as the volume 2. Here represent the final volume at the final condition. Okay, so this one will be using at the calculation. So will be applied at the learning center 5. Later on, I show you few past year question how we apply this formula. Okay, then we go to the graph. Okay, so which graph is actually showing the relationship between the P and V or Boyle's law here. Okay, so here the firstly you can see according to this formula here. So we are very clear that P and V is inversely proportional. So the graph will be like this. Okay, so where you actually already learned at chapter 1. Okay, chapter 1, and then the graph also can be drawn as P against 1 over V. Okay, so it will be one straight line passing through the origin here. Okay, so here will be directly proportional. So P is directly proportional to 1 over V. Okay, so later on, I will show you the detail of the experiment, how we get these two graphs. Okay, so besides that, you can see just now we have the formula here, right? PV equal to constant. Okay, so how the graph showing that this is the PV equal to constant. So this is the first graph. You can see PV is at the y-axis. So the changes of the P will be showing PV is still in constant. So be a parallel straight line to the x-axis here. Okay, so here will be also the same for PV against the V here. Okay, then the next, if the graph P against PV, so the PV now is at the x-axis. So that means the graph showing PV is constant will be here, lah, which is the straight line parallel to y-axis here. Lah. Then here V against PV also the same, will be showing a straight line. This straight line which is parallel to the y-axis, where here is a V. Okay, so if let's say you have any question, you may just ask me at the chat room. Okay, I will try my best to answer you. Okay, and then the next will be the experiment. Okay, so where the learning standard 2 is highlighted for the experiment to investigate or to study the relationship between the V and the P here. Okay, so the procedure. Firstly, here will be discussed regarding the inference. Okay, so inference will be right like this. This one will be the technique answering for paper 3. Okay, so first we need to identify the RV and MV here. So as per mentioned just now, the MV will be volume, then the RV here will be the pressure. So we'll be using the same method. The effect will be here. So volume of the gas at constant temperature affects the pressure of gas. So here will be the MV. Here will be the RV. Okay, sometimes we actually not mention constant variable also. No problem. You can just give volume of gas affects the pressure of gas also correct. Okay, so the next here will be the hypothesis. So hypothesis here will be, as per mentioned just now, the relationship between V and P will be inversely proportional. So that means when the volume of gas decreases, the pressure will be increases. Okay, then the next here will be the M. Okay, so to determine or to study the relationship between the volume and the pressure, where the mass is fixed, control variable, and the temperature also control variable here. Okay, so we are very clear that the constant variable here, C here will be referring to mass and the temperature. Then for the MV will be referring to the volume, and the responding where the parameter or quantitative physics are going to measure will be the pressure here. Okay, so this is actually I just take from the textbook. Okay, you can just referring to textbook. Okay, and then here will be the apparatus involved: 100 ml syringe, rubber tube, pressure gauge, and red dot stand. So you can just see at the figure. So all the apparatus will be arranged as per this figure. Okay. Okay, so procedure. First, set out the apparatus as shown in diagram. Okay, so this is a method how you write the procedure in paper 3. Firstly, you need to draw the arrangement of the apparatus, and then you give the first sentence. This will be the first mark for the procedure. You need to draw and label the apparatus. Okay, then second, adjust the piston. You can just look at the GIF lah. You can firstly, okay, adjust the piston so that the volume of the air in the syringe is 50 ml. Okay, so I'm using 50 ml in my experiment together with my students at school lah. So then connect the end of the syringe to the pressure gauge. It will be this lah, or this. Okay, so this is the first MV you are going to write. Okay, then take initial reading of the volume and the pressure. So you have to take reading at the syringe, which is showing 50 ml, and then you need to read the reading of the pressure gauge here, okay, which is the responding variable here. Okay, record in the table. Okay, so this will be the first responding variable you are going to write in your paper 3. Okay, you have said the question asking you the amali jenis tidak berbantu. So that means the procedure is not provided. You need to write according to the question given. Okay, so the table will be here. Okay, so the table you must give the symbol. If I say you not write volume is no problem. So you have to give symbol. You need to give the unit. Okay, and then each also the same. You can see here must have symbol and unit, symbol and unit. And here the value you write here must be according to the sensitivity of the apparatus you use. Okay. Okay, then here, the first reading I get together with my student here is about 20.1. Okay, then the next here will be push the piston slowly until the volume of the air in the string become 40 ml. Here is actually 40 ml. Take the reading of the pressure and record it in the table. So you will record the second reading. Okay, so normally we will straight away write down. Repeat the step 4 with the volume of 30 ml, 20 ml, and 10 ml. Okay, you can look at the table here. Okay, and then record all the pressure P in table. So that means here, the next step here, you have to repeat another 4 MV and RV at your step. Okay, so that you can get full marks for the procedure. Normally it will be 3 marks to 4 marks here. Okay, so this is the reading where I get together with my students. Okay, and then the 1 over V. Okay, so for this experiment, you are going to draw 2 graphs. Just now I explained to you already. So when P against V, we expected inversely proportional graph will be like this. And then for another graph will be P against 1 over V. So we'll keep directly proportional. So it's a straight line passing through the origin. Okay, so here you just need to use this formula. 1 divide 10. So you get 0.100. Okay, so here you must make sure that your second reading here, secondary reading, that means that will be the reading where you get after calculation. Okay, so for just now, this one is considered as the primary reading. Primary reading, you must follow the sensitivity of the apparatus. Okay, so you can see when you give 1 decimal places, which is according to the sensitivity of the apparatus, you must always give the same numbers of decimal place here. Then for the secondary reading here, so you can just give 2, 3, 4 decimal places also, no problem. Okay, so here is actually incorrect. So you have to give 0.050 because all reading I showing here with 3 decimal places. So must be always the same here. So when you write your answer in paper 3. Okay. Okay, so this is just the reference reading for you. Okay, so now the next step will be plot the graph P against V. Okay, so this is the reading where I transfer to previous slide. Okay, so to draw P against V, we use these two raw data here. It will be here and here. Okay, so as per mentioned just now, for graph P against V, we expected the graph will be like this shape, which is P inversely proportional to V. Okay, so this is a graph paper, okay? Okay, so to draw the graph, you need to give symbol or parameter. And then you need to give unit. Okay, and then your size of the graph must be 5 unit times 5 unit. 5 unit minimum. Okay, and then the skill must be multiple 1, 2, 5, or 10. Okay, so here 20, 40 still considered as 2 lah. Okay, so this is considered as a uniform skill. Okay, let's say you not give the uniform skill will be what? Example 1 to 3, 1 to 5. 5 is considered as a uniform. 6, 7. Okay, so this type of the skill is actually considered not uniform. So we deduct the mark at your paper 3 lah. Okay, so so I get the data. First point will be 118.7. So it'll be about here. P V will be 10. So this is the first reading, first point. Okay, and then the next here will be the 20 together with 79. So 20 will be here. 79 will be almost here now. Okay. Okay, then another 3 point will be here. So just now I mentioned to you, you need to have minimum 5 reading for your experiment. Okay. Okay, so that you can join, the line will be almost like this now. So this one must be draw freehand now. Okay, so you can see the shape is similar to the theory you learned just now in the previous slide. Okay, so the next will be the another graph, which is the P against 1 over V. Okay, so you can see here, plot a graph P against 1 over V. Okay, again, I'm using the same data. So now we focus to P and 1 over V, which is requested by the question. Okay, so again, we expected there is the straight line passing through the origin. Okay, because the P will be direct proportional to 1 over V here. Okay. Okay, so again, the unit, a symbol, unit, correct skill, and your graph must be bigger than 5 units. 5 units times 5 units, okay? So the first point will be 0.02 with 20, this point, okay? 0.02, actually it's shifted a bit, it's actually is here, okay? And 20.1. Okay, and then second will be 0.05, 0.025 with 34.3 will be here. Then others will be another 3 point will be this lah. So again here it's correction, we must have the same decimal places. Okay, so straight line must be passing through the origin. Okay, so the data here is actually not so good lah, okay, because the distance here a bit far. Actually, you need to be more close. Okay, but still meet the minimum requirement where the above numbers of point 3, you can see 3 point here, minus 2 point here. So you get 1 or less than 1. So that means this is considered the best line for my data here. Okay. Okay, so the conclusion here, we are very clear that the experiment showing that the volume of the gas decreases, the pressure of gas will be increases. So this is a conclusion for the first experiment. Okay, first law of the experiment here. Okay, so we have already finished our second learning standard regarding a Boyle's law. So now we go to our third learning standard. Okay, so the third learning standard, you need to able to understand to conduct the experiment to determine the relationship between volume. Okay, so the volume and the temperature. Okay, and the mass and pressure now is constant. So this is the Charles' law you are going to discuss with me now. Okay, so before we go to the experiment, we also go to the detailed discussion for the Charles' law. Okay, so as per mentioned just now, the Charles' law, we study the relationship between the V and T, volume and temperature. So the relationship will be able to represent by this equation, okay, will be directly proportional. So that means when the temperature increases, volume will be increases. Okay, so Charles' law is also able to describe, explain by using the kinetic theory of gas. Okay, then here you can see diagram show the fixed mass. The fixed mass here showing that the numbers of particles for both is the same. Okay, although the volume 1 is smaller than volume 2 here. Okay, and then this experiment will be conducted with constant of the pressure. So you can look at this GIF. So the volume of gas is changes, the temperature is changes, and the pressure here is always a fixed here. You can see it's fixed. So we expected the graph will be a straight line passing through origin, which is with this formula just now we explained already at learning center 1. Okay, so you can see here when the temperature of the gas increases, the average kinetic energy of its molecule increases. Okay, then the molecule moving with highest velocity. Just now I also using the GIF to explain to you. So the temperature is measuring for the kinetic energy of the molecule. So the formula, kinetic energy will be 1/2 mv squared, right? So when the V increases, the kinetic energy will be increases lah. Okay, clear everyone? Okay, then the next here, you can see to keep the constant pressure, so the volume of gas increases so that the rate correction of the gas molecule against the wall container will be unchanged. Okay, so you can look at this GIF. So if I say the volume is not allowed to increase or change when the temperature given, when the heat is given, the temperature will be increases. So the particles will be collide more frequently against the wall container. So the pressure will be changes. But to meet the Charles' law, the pressure must be constant. So to make it constant, so that means the rate of collection against the wall container must be the same. So that we need to increase the volume when the heat is provided to the particles so that the frequency fraction against the wall container by the gas molecule will be constant. Okay, so this is explanation of the Charles' law by using the kinetic theory of gas. Okay, so the next here will be definition. Okay, so the Charles' law states that the volume is directly proportional to the absolute temperature T with the fixed mass and constant of pressure. So again, the formula will be like this lah. V is directly proportional to T here. Okay, so what is means by the absolute temperature? So why we cannot write as temperature? Because we need to using the Kelvin scale when we applying the Charles' law. Okay, so now I'm going to explain to you what is the absolute temperature. Okay, so the absolute temperature is the temperature measured by using the Kelvin scale. Okay, so the conversion between the degree Celsius and Kelvin will be by using this formula lah. So T will be the temperature in Kelvin. The theta will be the temperature in degree Celsius. Okay, so here we have a table to discuss how we converting the unit of temperature between degree Celsius and Kelvin. Okay, so you can see the first, we already know that the melting of ice will be at 0 degrees Celsius. So when 0 degrees Celsius converting to Kelvin, you need to apply this formula. We need to plus 273. So in Kelvin, the 0 degrees Celsius will be equivalent to 273 Kelvin here. Okay, then the steam will be at 100 degrees Celsius. Converting to Kelvin will be plus 273. So we get 373 here. Okay, so now we have another new terms here, absolute zero. So we know already what is the meanings by the absolute temperature. So that means the temperature is measuring by using the Kelvin scale. So what is the absolute zero? Okay, so here you can see the definition will be like this. Absolute zero is actually 0 Kelvin, which is equivalent to negative 273 by applying the same formula here. So it's the temperature at which the particles of the metal have the minimum energy. So this is the meanings of the absolute temperature, absolute zero here. Okay, so when the particles is at the absolute zero, so that means the volume and the pressure of the gas will be zero. So this is a theory for the real gas. Then the kinetic energy of the gas molecule becomes zero. And the gas molecule are stationary. So it's not moving. Okay, so because of the particles is not moving, so the kinetic energy is zero. Okay, so here, as I mentioned just now, the absolute zero will be 0 Kelvin. So when we convert to degree Celsius, so be minus 273. So we get negative 273. Okay, so this is regarding the discussion about the absolute temperature and absolute zero. So that means in your definition, you must write absolute temperature here. And you must using Kelvin in your calculation. Okay, so now let us go to the formula going to apply in this section. Second law, Charles' law here. Okay, so V equal to KT. So K will be constant. Constant. Okay, so we get V over T equal to constant. Okay, so the formula apply will be V1 over T1 equal to V2 over T2. So your T must be in Kelvin. Okay, so again, V1, T1 will be the volume, initial volume and initial temperature. Okay, and then the V2 and T2 here will be the final volume and final temperature. So the problem solving by applying this formula will be at learning standard 5. Okay, later on I will discuss with you all with few questions. Okay, then the graph involved here, firstly, as I mentioned, the V will be direct proportional to T. So it will be a straight line passing through origin. And you can see the unit we're using for temperature here referring to Kelvin. Okay, then the second graph involved here will be the extrapolation of the graph. V against T. Here actually using theta, or if I say you see at the book. Theta is referring to the temperature in degrees Celsius scale. Okay, T will be for absolute temperature. Okay, so here is the experiment I'm going to discuss with you after this. Okay, so the Charles' law experiment, actually you just can get your data between the room temperature, or you can get maybe lower by using ice. Then maximum actually you can achieve until 100 Okay, so this is the measurable area for your experiment. Okay, after you get this data, so you need to do extrapolation. This line, the dashed line here. Okay, so you'll get your absolute zero here. So the reading here is about negative 273 as per explanation just now. Okay, then the C will be V over T equal to constant. So this is another 4 graph showing that where the graph is meets the Charles' law. So here will be V over T against V, and V over T against T will be constant, where the straight line will be parallel to the x-axis. When go to the V against V over T, so will be a parallel line to the y-axis. Okay. Okay, so here we are going to discuss the experiment to study the relationship between the volume, V, and the temperature. So where the P will be constant together with the mass. Okay, so here the inference, just now I already mentioned to you, okay, we will put effect at the middle. So the front will be referring to RV, then the volume, front will be the MV. So this will be the RV. Okay, so temperature of gas affects the volume of gas. Okay, so the hypothesis, when the temperature increases, volume is increases. This one we already discussed the theory regarding the Charles law. Okay, and then the aim of the experiment is to study the relationship between the volume and the temperature where the mass is fixed together with the pressure here. So the MV will be referring to temperature. Okay, so again, we're using simple data showing that the unit degree Celsius will be used for our measuring during the experiment. Okay, and then the responding variable will be volume. The constant here will be the mass and the pressure of the air. Okay, then we discuss the apparatus listed. Here we have the capillary tube containing air trap. So be this now. Okay, so you can see at the GIF, when temperature increases, the L, the length of the air of the column here will be increases now actually. Okay, and then we have the meter rule, red dot stand, and others lah, which you can see here already labeled at the figure lah. So this is the arrangement of the apparatus. Okay, so again, when you want to write the procedure, first step you have to give this sentence now. The apparatus are here got spelling error. Apparatus is set up as shown in the diagram. So you have to draw diagram and label. This will be the first mark. Then second, give your first MV. Okay, so my MV here first I using 60 60 degrees Celsius. So the water in the beaker is heated slowly and stir uniformly. So you can see here we have a stirrer. Okay, so here you can see we have a stirrer. So we have to stir so that the temperature of the water will be equal for whole beaker. Okay, then we measure the length of L here. Okay, so the length of the air trapped air. So we measure the L, capital L here. You can see at the figure lah. So we are going to measure the length. Okay, we not measure volume. Okay, because the length times the same area will be get volume lah. Okay, so we just need to compare the length. So this length will be represented volume already lah. So this will be the first MV and first RV. So be the second mark. Okay, then the third. Okay, so you need to label lah your reading. So my reading I get will be 17.6. Okay, then the next will be again, you need to repeat your experiment of step 2 lah. Okay, for another 4 reading, minimum 4 reading lah. So this is the reading I did together with my students. Okay, and then this will be the 4 MV, and then this one you need to measure again the length of the column. Okay, so this one will be the 4 RV. So you will get full marks. Normally it will be at the range of the 3 to 4 marks for procedure. Okay, so this is my reading. Okay, 17.8. So this is what we expected. When temperature increases, the volume increases. So that means here the length will be increases. So this is a logic reading where you must know when doing the experiment. Okay, so again, we need to draw the graph L against theta. Okay, so this is my reading. Okay, so the hot tips just now I explained to you already. So where we can just get the area – where possible, did possible do at your school. Okay, at about room temperature to boiling point, actually you can get lah. Okay, and then you need to do a separation and get the absolute zero here. Okay, so the graph will be about like this lah. Okay, so again you need to give you need to label symbol, then you need uniform scale for x and y. Okay, and then the graph must be more than 5 units times 5 units. Okay. Okay, so my first reading here will be 60 together with 17.6 lah. Okay, will be here. Then second reading will be 17.8 to 65. So this is another 4 reading. So where is actually very close lah. Okay, will be here lah, actually very close. Okay, so as per theory, so we expected a straight line will be needed to extrapolate until we get the absolute zero, which is about -273. Okay, so it'll be like this. Okay, so this is the you will get the straight line at this area first. After that, you do extrapolation now. So this will be the method how you draw this Charles law graph. Okay, so you can get your absolute zero is almost nearly to -270 lah. Okay. Okay, so the conclusion here will be the temperature increases, the volume will be increases lah. Okay. Okay, so now is the time for take 2 minutes of the break. Okay, so see you all later. So we go to the break first. Okay, so welcome back. Okay, so let us continue the next learning standard. Okay, learning standard 4. Okay, so the learning standard 4 here will be regarding the Gay-Lussac law. So the Gay-Lussac law just now I explained to you will be the same meaning as the pressure law here. Okay, so the learning standard 4 you need to able to understand the experiment and conduct experiment where have to determine the relationship between the pressure and the temperature. Okay, so where the mass will be fixed and the volume will be constant here. Okay, so here we are going to discuss the Gay-Lussac law, which is also known as the pressure law. Okay, so the relationship will be between the pressure and the temperature. Okay, so the formula here will be P direct proportional to T. So that means when the temperature increases, so the pressure will be increases lah. Okay, so now let us explain the Gay-Lussac law by using the kinetic theory of gas. Okay, here the first will be the diagram shows the fixed fixed mass of the gas being heated at a constant volume. Okay, so you can see here, before and after both is actually with the fixed mass. So that means the numbers of the particles before and after is actually the same. Okay, and then here the volume of the container before and after is also the same here. Okay, and then the second, when the temperature of the gas increases, average kinetic energy of the molecule increases because of the formula E equal to 1 over 2 mv square So the molecule will be moving at a higher speed. Okay, so this will be referring to this formula again. So when the V increases, kinetic energy of the particles will be increases now. Then the temperature is measuring the kinetic energy, average kinetic energy of the molecule. So when the average kinetic energy of molecule increases, so that means that the temperature will be increases now. Okay, and then the next here, the volume of the gas does not change, so you can just look at the figure now. So the container is the same volume. Okay, so when you can look at the GIF here with the low temperature, which is without heat provided. Okay, so the reading of the pressure here using the pressure gauge, Rodent gauge also can. So the pressure is low. When with heat provided, temperature will be increases. Then the reading of the pressure is increases here. Okay. Okay, so when the kinetic energy of the particle increases, so that means here the collection against the wall container increases. So the F over A, force per unit area of the wall or container, will be increases also lah. So when F over A increases, so P will be increases. So this is the kinetic theory of gas, which able to use to discuss or explain the Gay-Lussac law here. Okay, so the definition, just now we also explained already. So the Gay-Lussac law or the pressure law stated that the pressure is inversely proportional to the absolute temperature. Again, absolute temperature referring to the temperature measured in the Kelvin scale. Okay, and here the constant variable here will be the mass and the volume. Okay, so can using this formula to simplify the relationship between P and T here. So which is inversely, actually is directly proportional. Okay. Okay, so the formula will be P equal to KT. So K will be a constant here. Okay, so you can see P over T is constant. So we have this formula lah. P1 over T1 equal to P2 over T2 here. So again, you must change your temperature in degrees Celsius to Kelvin when doing the calculation. So the graph involves P direct proportional to T. So T here referring to Kelvin, so it will be passing through origin. And then another graph will be quite similar to Charles' law, but here we measure pressure lah. For the Charles' law, we measure the volume. Okay, so here again, the data you get will be room temperature to about you can get until the boiling lah. Okay, but normally will be at suggested value in your textbook already. Okay. Okay, so another graph will be P over T is constant. So will be P over T against P. You can see here the straight line will be parallel to x-axis. And P against PT or T against PT here will be a straight line parallel to the y-axis. So this four graph showing that this actually meet the Gay-Lussac law here. Okay, so you can actually draw your answer from my worksheet. Okay, so again, the worksheet you can actually download with this link. Okay. Okay, so the next here will be the experiment, okay, regarding the galvanic law or the pressure law, which will be study the relationship between the pressure of the gas and the temperature of the gas here. Okay, so the inference, just now I saw already, teach you how to write. The middle here you can write effects. So the front here referring to the MV, pressure here referring to RV lah, oh. So temperature of gas affects the pressure of gas. Okay, so hypothesis, just now below already, the T and P will be direct proportional. So that means when the temperature of the gas increases, the pressure will be increases. Then here, M to determine or to study the relationship between pressure and the temperature. So one will be here RV, one will be MV at the fixed mass and the constant volume. Okay, so the variable here will be, for the manipulated will be temperature. Again, data showing that the measurement we do or we conduct experiment here is actually degree Celsius. Okay, and then the responding variable will be, we are going to measure the pressure. Then the fixed variable will be mass and the volume. Okay, the apparatus listed will be Bunsen burner. Okay, then round bottom flux. So will be similar to this figure lah. Oh. So again, you can see you need to draw and label correctly lah. Okay, so this is the diagram I get from the textbook lah. Oh. Okay, so the first step when you write the procedure, first step must be the apparatus is set up as shown in the diagram. So you must draw with this sentence lah. So this will be the first mark when you answering for paper 3. Okay, and then second, the mixture of the water and ice is stirred continuously so that the ice in the flux have the same temperature with the water. Okay, so the A in the flux, okay, A is here. Actually, here is empty. So here is the A. Okay, so that the air in the flux has the same temperature with the water. So that means you need to stir continuously so that the temperature of the air inside the flux is same as the water surrounded here. Okay. Okay, and then this is a precaution actually. This is can be made as the precaution. Okay, when the reading of the thermometer reach 30, so this is the first MV. Okay, so the P on the Rodent gauge is recorded. So this is the pressure gauge. Okay, we need to read the reading here. So that means here will be our first RV, first MV and first RV lah. Okay, then repeat the experiment with different temperature. So here you need to give another 4 lah. 40, 50, 60, and 70. And the value of the pressure of the air, okay, is tabulated. So be like this lah. Okay, so again, in your table must be have symbol, unit, okay, and then you need to have the primary reading, right? So here will be need follow the sensitivity of the apparatus lah. Okay, so the reading I did together with my students here will be this lah. Oh. So you can see when the temperature increases, so the pressure is increases. So the reading we get is actually logic lah. Oh. Okay. Okay, so here plot a graph of L against theta. So here will be similar to Charles' law. Okay, so I applying the reading, this reading, and then again you see, just now I explained to you, you need to do extrapolation because we just can get reading at this area. Then out of this, you need to do extrapolation. Okay, so the graph will be almost like this. Again, you need to give symbol. You need to give unit. You need to give uniform scale for S and Y. And your graph must be greater than 5 units times 5 units. Okay. Okay, so here will be my first reading, where will be 30 with 84. 30 will be about here, and 84 lah, will be first. Then here I have another 4 reading, will be 40 together with 87 and others lah. Okay, so again, this is you will get line at this area first actually. At this area, straight line here. Then you do extrapolation. Okay, so you will get your absolute zero is here. Okay, so the absolute zero here will be about negative 273 degrees Celsius lah. Okay, so the conclusion here will be when the temperature increases, pressure will increases lah. So this is the definition for the Gay-Lussac law or pressure law. Okay, so we go to our last part, last learning standard 5. Okay, so will be problem solving. Okay, so solving the problem involving pressure, temperature, and volume for the fixed mass of gas using gas laws formula. So just now we have 3 formula. Okay, so the first one, Charles' law will be P1 V1 equal P2 V2. So this not Charles' law, Boyle's law. Then Charles' law will be V over T, V1 over T1 equal to V2 over T2. Then the Gay-Lussac law will be P1 over T1 equal to P2 over T2. Okay, so the Avogadro law will be learned from 6th chemistry actually. Okay, semester 1 lah. Okay, so here we just focus 3 gas law here, Boyle's law, Charles' law, and Gay-Lussac law. Okay, so here we are going to discuss 6 questions. Okay, so students, you may key in your answer in the chat room. Okay, so that I know that you learn together with me. Okay, so the question 1 is actually the past year question of SPM 2015. Okay, so the question will be like this. Diagram 17 will be this. Shows the pressure of the car tire, which is 200 kilopascal. Temperature will be 30. So after a long journey, okay, so definitely the friction will causes the temperature of the tire increases. So now increases to 60. So you need to find out the new pressure. So that means here 200 will be P1. This will be T1. P and T referring to Gay-Lussac law actually, right? So and then we have the value of T2. You need to find out P2. Okay, so this question is very easy actually. Okay, so you just look at the figure so that you know P1 equal to 200 kilopascal. T1 will be 30 degrees Celsius. Again, you must remember, change the degree Celsius to Kelvin, okay, in your calculation. Okay, so here, just now I've explained to you, relationship between P and T, so we'll be applying the Gay-Lussac law. So the formula we're going to use will be this. Okay, so the reading of P2 is 60 degrees Celsius. You need to convert to Kelvin also lah, plus 173. Okay, so substitute to the formula, so you get your answer is 219.8. Okay, so answer here will be B lah. Okay, okay, then the next here will be question number 2. This one also objective question from past year question also on 2016. Okay, so this one is also calculation. Okay, so diagram 11 shows the syringe connected to a Bourdon gauge with this measuring for pressure. The reading of the Bourdon gauge is 1 times 10⁵ Pascal when volume of the air is in the syringe is 40 cm3. Okay, so what is the new reading when volume of air is 10 cm3? So that means here we have P1, we have V1. So that means P and V referring to Boyle's law lah, right? Okay, so now question asking you to get the new reading of the Bourdon gauge. So that means we need to find out the P2. Then when the volume of air decrease to, this one is V2. decrease to 10. Okay. Okay, so that means here when the volume decreases, the pressure is expected increases now, because the the Boyle's law tell us the P and V is inversely proportional. Okay, when V decreases, P is increases now. Okay, so here this is the value given now. So P1 equal to 1 times 10 power 5. Okay, then V1 is 40. Then we need to get P2 with the volume decreases to 10. So here we applying Boyle's law with this formula. P1 V1 equal to P2 V2. Okay, so we substitute all the value. So we get 4 times 10 power 5. Okay, so we get answer A lah. Okay. Okay, then we go to the third question. Okay, so here is the theory. Okay, so look at the question together. So diagram 13 shows the condition of the plastic bottle which initially contains hot air. So here you see hot air before and after being put into the basin of ice. So you can see when the bottles put inside the ice, it shrinks already lah. So the volume decreases long. Okay, so the above situation can be explained by which law actually? Okay, so firstly, temperature is higher because it's a hot air. Okay, so here you can see it's a normal size of the bottle lah, but the size is larger compared to put inside the ice already. Okay, so you can see at ice, T is lower. Then volume becomes smaller because shrink already. You can see from the figure here, looking the diagram 13 here. So when we discuss T and V, so that means we discuss about the Charles law lah. You can see when the temperature decreases, volume decreases lah. So V and T is directly proportional. Okay, so the answer here will be C. Okay, and then the next here will be the checkpoint 4.4. Question number 4. Okay, so here will be another objective question at 2010. Okay, so diagram 15 shows the pressure temperature graph. So pressure temperature. So that means here is actually Gay-Lussac law or pressure law lah. Okay, so this is what the discussion regarding the experiment we did at the Learning Standard 4. Okay, so which statement is correct about the condition of the gas? Okay, so here the gas pressure is 0 at 0 degrees Celsius, correct or not? Okay, so here the hot fix here is at the absolute temperature. Absolute 0 actually is absolute 0. Okay, so the gas molecule is not moving, therefore the kinetic energy is 0. Okay, so the mistake for air will be actually 0 Kelvin. Okay, then the B, the gas molecule are stationary at negative 273. So it's correct. You can see the statement when at absolute 0, kinetic energy is 0. So B will be the answer actually. Okay, so the C, the kinetic energy of molecule is maximum. Wrong lah. Suppose is minimum as per explanation of the definition just now at the previous slide. Okay, and then the D here will be the gas pressure is inversely proportional to temperature. Wrong lah. This suppose directly if according to Gay-Lussac law lah. So answer is B. Okay, so next will be paper 1 question. Okay, we do another 2 questions here. Okay, so this question is from 2011. Okay, it's regarding the conception. Okay, so you can see the question together. Diagram 5.1 and 5.2 show trapped air in 2 identical flasks heated with different quantity of heat. Okay, so both stoves are turned off after 10 minutes. Okay, so initial, here you can see temperature is minimum. Or you can see this minimum is here. So it's at the middle. So we see the reading of the pressure showing by the Bourdon gauge here is lower. All the reading is here. Then another one, you can see the stove, the temperature of the fire using, okay, is greater. So the Bourdon gauge reading is greater now. Okay, so here state the physical quantity measured by Bourdon gauge. So be this. So it's measure actually what? So it's actually measure the pressure, air pressure. Okay. Then the next here will be compare the reading of both Bourdon gauge. So here, first Bourdon gauge, just like I mentioned to you. Okay, so the reading here is actually smaller. Okay, here is smaller. Okay, then this one will be bigger value. So that means 5.1 is smaller than 5.2. Okay, so you can use symbol. Okay, you can see here 5.1 is smaller, the reading. So you can using a symbol. 5.1 is smaller than 5.2. Okay, using symbol to give your answer is very easy. Okay, and then the next will be compare the reading of thermometer. So where is the thermometer? So you can see here the reading. Here is actually, you can see the black line until here. Okay, then for the second one, 5.1 actually is higher, right? The black line is until here. So that means here the reading of the thermometer for diagram 5.1 is smaller than 5.2. You can just observe the line here. Okay, so that means 5.1 is smaller. You can again using symbol for your answer. Okay, then the next here will be state the relationship between the heat supply and temperature. Okay, so when heat provided, the gas molecule will gain kinetic energy. So be moving at higher speed. So when the average kinetic energy increases, the temperature will increases. So that means increase for the answer. So answer will be the temperature increases when heat increases. And the next will be set the relationship between the pressure of air with the temperature. Okay, so you can see when the temperature smaller, reading of pressure also smaller. Or you can give vice versa. Here, maximum, right? So you can see the indicator pointer here. Maximum greater temperature, pressure showing by the Bourdon gauge will be greater also. So when the temperature increases, the pressure of the flux increases. Okay, then the next C, based on the theory, kinetic theory, explain the reason why 5B4. The answer for 5B4. So the answer from 5B4 is when the temperature increases, pressure increases. Okay, so why? As per explanation just now, this one will be regarding the Charles' law. Will be the Charles' law. Temperature with pressure. Temperature with pressure is actually referring to Garu's law. Okay, so when the temperature increases, the kinetic energy of the particles increases. So causes a collection of the particles to the wall container increases. Okay, so the pressure increases. So here reference answer, when molecule in the flux receive heat, they move faster. First mark. Second, this causes kinetic energy of molecule increases. Then the kinetic energy of molecule increases, the collection between the molecule increases, thus increases the air pressure in the flux. So you can see here, we have three reference answer. Maximum will be 2. So you can actually write more, okay, the relevant answer. Okay, because sometimes the answer you write might not meet the scheme, right? Okay, so you can write more than 2 points actually. 2 marks, you need to give minimum 2 points. Okay, then the D, name the law involved. Okay, so you can see just now, I explained to you already, is regarding P, pressure together with temperature. So it will be pressure law or Gay-Lussac law. Okay, it's regarding temperature and pressure. So you can give Gay-Lussac law or pressure law. Both is correct. Okay, you can give pressure law also. Okay, then the next will be question number 6. This is a partial question from 2018. Okay, so this one is actually the section C. Okay, it's a partial question. I just take the calculation. Okay, so this will be the last question. Okay, so the atmospheric pressure is equivalent to 10 meter of water. So meter of water is the unit for pressure when you're using water as a instrument to measure the pressure. Huh? Okay, so you just imagine this is a pressure unit. So this one we have actually further study for liquid pressure at the Form 5 syllabus now. Huh? Okay, so what is the total pressure add on the bubble in the unit of meter water? So when the air bubble is at the surface, another one is at the depth of 60 meter under the water. Okay, so you can imagine with this figure. So B will be at surface. So air will be deep of 60 meter. Okay, so the surface air bubbles is bigger actually because it's only added with atmospheric pressure. Okay, so the question given us, atmospheric pressure will be equal to 10, right? So the answer for pressure against or adding to the air bubbles at the surface will be actually 10. So you have to give pressure at surface equal to atmospheric pressure. You have to give 10 and unit together, meter with meter of water. Okay, then the second one will be at the 60 meter underwater. So that means here is actually got another pressure, which is known as the liquid pressure. Okay, so this one will be further study for the Form 5 Chapter 2 actually. Okay, so here total will be atmospheric pressure plus the liquid pressure given 60. So total will be 70 meter water of water lah. So this is the answer for the first one, 2 marks. 1 mark for each. Okay, and then the next question, okay, so this one will be the theory for Form 4 lah. Okay, so here the volume of the air bubbles at the depth of 60 meter is 1 cm cube. So this will be the V. You can give V, V1 also can. Okay, so calculate the volume of bubble at surface. So this one will be V2 lah. So you can imagine like this lah. So here for the surface bubble, volume will be, okay, so I'm using V1 for surface. Wait, for the A, deep under the water lah. So my V1 is actually here. So here I label already. So V1 is 1 for the bubble size, and the pressure added to the bubble A here will be 70. This one is calculate at question C just now. Okay, so calculate the volume. So you need to calculate the volume, the size of the bubbles, this bubble, V2, when the pressure added is 10. So we expect it's bigger lah, because when pressure lower, V will be greater according to Boyle's law lah, right? Okay. So again here, the question highlighted here is actually application of the Boyle's law here. So given P1 is not given now, you get the answer from C. This one C2. Okay, this one you get from C1. So 70 and 10 here. Okay, so we just substitute to this formula. P1 V1 equal to P2 V2. So 70 and 1 equal to 10 times V2. So we get V2 equal to 7.0 CMQ lah. Okay, so this is how we apply the voice law in this question. Okay, the section C, if I say I'm not mistaken, is a partial question. Okay, at 2018. Okay, so that's all for my discussion. Okay, for subtopic 4.4. Okay. Okay, so okay, so tahniah dan terima kasih diucapkan kepada semua pelajar yang setia mengikuti kelas sehingga sekarang. Okay. Okay, so sebelum kita tambahkan kelas sesi siaran langsung ini, mohon tutup ruangan chat, klik butang subscribe dan aktifkan ikon loceng supaya anda tidak terlepas sesi kelas daripada saya. Okay, dan seterusnya. Okay, so sila klik like dan share link kelas kita pada hari ini kepada rakan-rakan di media sosial anda. So mudah-mudahan pelajar beroleh kebaikan di atas perkongsian tersebut. Okay, so terima kasihlah kepada semua penyokong Akademi Youtuber. So doakan kami terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan di Malaysia. Okay, so sekian daripada saya. So salam hormat dan jumpa lagi. Okay, so bye-bye.